The following set of lessons, brought to you by MechNet Incorporated, will deal with the fascinating subject of aerodynamics. Aeronautics is a science that studies the movement of air and the way that objects, such as airplanes or cars, move through the air. Or stated as, the qualities of an object that affect how easily it is able to move through the air. It is a branch of dynamics that deals with the motion or air forces acting on objects as they move through the air. There are three main methods for testing the aerodynamics of an object. Study the air over an object by actually moving through the air or flying the airplane. Place the object in a wind tunnel. Or use CFD to study air forces around an object. All three methods can be used in aeronautical test, and each method has its advantages and disadvantages. Here is a picture of an experimental airplane being tested by flying through the air. This is an example of an airfoil being tested using CFD, Computerized Fluid Dynamics. For our studies, we will be using a wind tunnel to conduct our aerodynamic testing. The preliminary work is usually accomplished with the use of a wind tunnel for safety and cost reasons. An engineer using a scale model of the airfoil or aircraft can perform a test without risking the life of a pilot if there's a failure. This allows the testing of radical new designs safely and efficiently. The cost of new designs is reduced by allowing changes to be made to the model quickly and tested without actually having to fly the airplane to perform the test. The history of the wind tunnel. One of the first wind tunnels was designed and built by Orville and Wilbur Wright. They were two American brothers, inventors, and aviation pioneers who are generally credited with inventing, building, and flying the world's first successful airplane. They made the first controlled, sustained flight of a powered, heavier-than-air aircraft on December 17, 1903. This is the first powered flight of an aircraft at Kitty Hawk, South Carolina. The Wright brothers with their invention. This is the wind tunnel used by the Wright brothers. When they began flying gliders, they found much of the data that was published at the time was not accurate. They determined they needed to develop their own data. They designed their own apparatus for testing the effectiveness of various shapes. Here are some of the shapes they tested in the wind tunnel. This is an example of the data they collected from their testing. Here is an example of why it is a good thing to try new things out in a wind tunnel first. Types of wind tunnels. There are two basic designs of wind tunnels: open loop and closed loop. The open loop design allows the air to enter the tunnel from the room and exhaust into the room after it passes through the tunnel. This is the type of wind tunnel we will be remotely operating at the MechNet facility. The closed loop design continually circulates the air within the wind tunnel. The closed loop design is generally used in larger wind tunnels. Wind tunnel components. The main parts of the wind tunnel are flow straightener, a honeycomb material which straightens the flow of air before it enters the contraction cone. Contraction cone allows the air speed of the air taken from the room to be increased before it enters the test section. Test section. The area where the models are mounted. This part of the wind tunnel will have the highest air velocity. The walls of the test section are usually clear to allow flow observation studies of the model being tested. The diffuser allows the speed of the air from the test section to decrease before re-entering the room. The fan generates the airflow which passes through the wind tunnel. The fan is driven by an electric motor and placed at the end of the return section. Wind tunnel testing methods. There are certain requirements which must be met before the data taken from the wind tunnel can be accurate. The airflow in the test section must be laminar. This means the flow is smooth layered, and the air streamlines will stay even and not vary in position with the other air streams. Simply put, the air will stay straight through the test section. In this drawing, we can see an example of how in a laminar flow condition, the lines are evenly spaced around the round sphere being tested. In this slide, we see an airfoil being tested with a laminar flow over the upper surface of the airfoil. The yarn tufts are all in a straight line. In this slide, we see an airfoil in a stall condition and a turbulent flow over the upper surface of the airfoil. The tufts are all moving in a random direction. Flow visualization techniques in wind tunnel testing. Since we cannot physically see the airflow over the model in the wind tunnel, often methods are used to aid in seeing how the air is flowing over the object being tested. There are several different methods of accomplishing this. The two main methods are smoke testing or yarn tufts. Some other methods often used are colored oil on the surface and hydrogen bubble testing, along with many other methods of visualizing the flow. Here is a technician using smoke to test the airflow over an automobile in the General Motors Aerodynamic Laboratory in Warren, Michigan. Here is an example of a combination of long and short yarn tufts being used to illustrate the flow pattern over the upper surface of an airfoil. Note the tufts on the front of the airfoil are showing a laminar flow, while the tufts on the rear are showing a detached, turbulent flow. The models being tested, if they are scale models, must be very close in proportion to the full-scale model with respect to dimension. Scale models are used to conduct tests on a certain shape without the expense of testing the full-scale model. If the model is a true reproduction in a smaller size, the test data will be valid. Scale numbers are often referred to as a ratio. A 10-to-1 scale would be 1/10 the size of the original size. Testing a scale model allows for the testing to be completed in a wind tunnel with a much smaller test section. This is a picture of a Flowtech 1440 wind tunnel located in a laboratory with a technician manually moving the yarn streamer to illustrate the airflow around the airfoil. Note the computer screen that is used to control the wind tunnel and display the data. Many tests are performed with the engineers in a separate room monitoring the test and storing data from the test in progress. They do not actually see the object being tested. This is very similar to the method you will be using performing a test with the MechNet equipment. This is the actual screen used to control the wind tunnel remotely. As you can see, the data screen to control the wind tunnel and display the data is the same as what was used to control the equipment in the lab. The 4415 airfoil shown on the screen is taken with a video camera mounted outside the wind tunnel. Since you cannot physically move the yarn streamer up and down as you saw the technician do, for the remote test we have added a feature that allows you to control the yarn streamer remotely with the slide bar labeled Probe Percentage. As you can see, there is virtually no difference between performing a test with a wind tunnel in your classroom and accomplishing the same test remotely via the Internet.